Okay, all right. You are welcome back. We are still in 6.6, section 6.6, which is the inverses. Okay, we are using, now we want to use the knowledge of finding inverse to solve a system of equation. In one of our previous videos, we use the method of augmented matrix, and then we reduce that matrix, and then we solve the system with that. Okay, that means in a system, when we have our matrix A, we have our X, which is our X1, X2, X3, and then we have our B. Let's assume B is 1, 2, minus 1. Okay, let's assume our A is 1, 0, 1, 0, 1, 2, 1, 2, 1. Okay, in this one, what we did previously was that we bring this right-hand side value to this matrix, and we get an augmented coefficient matrix. We got an augmented coefficient matrix where we now put our A, and B side by side, and then we perform row operations on this matrix until the whole thing is a reduced matrix. Okay, until the whole thing is a reduced matrix, and then we'll now be able to get our X1, our X2, our X3. Okay, that is what we did in one of the previous videos. Please make sure that you watch that so that you can understand about that. But here now we want to solve using the inverse method. That means we are going to be writing out our matrix A, which is this. Okay, our matrix A, this is our matrix A. This matrix A is gotten from this system. Okay, that means X1 is 1, X2, well, there's no S2 here, so it's 0, S3 is negative 2, S4 is S1 in this one is 4, S2 is negative 2, S3 is 1, X1 1, S2 2, X3 10. Okay, these are our matrix. Of course, these are our B, but we are not going to be writing the B side by side with this one. So we have 1, 2, negative 1. This is our B. All right, so in using the inverse, by using the inverse or finding the inverse first, this time around, we want to solve this system by finding the inverse. Okay, so in order to solve it by finding the inverse, we use this matrix A, and we put it side by side with identity matrix. Okay, that's what we need to do. We put it side by side with identity matrix. So I write matrix A again. Matrix A is 1, 0, negative 2, and then we have there 4, then we have negative 2, 1. Let me check if I'm correct. Yeah, that's fine. Then we have 1, 2, negative 10. Okay, that is our matrix A. We are going to put it side by side with identity. We're going to put it side by side with identity, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, we're going to put it side by side with identity. All right, so now we need to reduce this to an identity matrix by performing row operation on it. And then as soon as we are able to get identity of this, then whatever is there is the inverse. Okay, so let's go. First, let's check this. This is already 1, so there's nothing to do there. So the next thing is to make this 0, to make this 0. Okay, to make that 0. So, okay, let's see the operation to perform on that. So we have R2 minus 4 R1, and then I'm giving it to R2. I'm changing R2. Okay, also we have R3 minus R1, and I'm giving it to R3. So I'm changing R3 also. All right, so performing operation on that, we are not changing one, so we leave that one like that. Okay, so if you perform this operation, of course, this will be 0. Okay, now if you perform that operation on R2 minus 4R1, we're going to be getting minus 2. Okay, R2 minus 4R1, we're going to be getting 9. R2 minus 4R1, we're going to be getting negative 4. And then again, 1 and 0. Okay, that's fine. For this R3, of course, this one is 0 because that's what we are using to change. Then this becomes 2. This becomes negative 8. R3 minus R1. R3 minus R1. This negative 1. This is 0. And this will be 1. R3 minus R1. Okay, that's fine. So let's go to the next one. This is already 0. This is already 0. Now the next thing is to change this into a leading one. This one to a leading one. Okay, to change that into a leading one, I just have negative 1 over 2 R2. Then I give it to R2. Okay, that is the only thing we are changing there. So every other thing remain the same. Every other thing remain the same. 0. This will be 1 now. This is negative 9 over 2. This is 2. This is negative 1 over 2. This is 0. This remain the same. They remain the same. Okay, that is fine. Now the next thing is to, this already 0, but we need to change this to 0. We need to change this to 0. So to change that to 0, we have R3 minus 2R1. R3 minus 2R1, and we are giving it to R3. R3 minus 2R1, and we are giving it to R3. So we have, this is not changing. That is not changing. This also is not changing. That also is not changing. Okay, now what is changing is this one. What is changing in that one? So and we are going to have 0, 0, and then we have another 0. We have 1. We have negative 5. Then 1, and then 1. Okay, so make sure you follow and make sure that you understand what is there. We are changing R3. Okay, that's what we're changing. Don't forget we are changing R3. We are changing R3. Okay, that's what we have there. That's what we have there. Okay, that's fine. Now, what do we need now? This is already a leading one. So all what we need to change is to change this to 0, change this to 0. Okay, this is already a leading one. Okay, so let's find the formula to do so. The formula to do so. So we're going to have, we're changing R1, so it's going to be R1. This is a negative, so plus 2 R3. Okay, and then we're giving it to R1. Okay, that's fine. Then we have R2. This is also a negative, plus 9 over 2. 9 over 2 R3. Then we are giving it to R2. Okay, that's what we're doing. All right, so let's perform that operation. Performing that operation, this is not changing. This is not changing. That is not changing. That is not changing. So if we do that operation on this, we're going to get 1, 0, 0. Okay, then that will give us negative 9. Yes, negative 9. We are putting that on R3. Now, negative 9, that is 9. This is 2, and then this is 2. Okay. For R2, let's perform this operation. That will be 0, 1. Now this is 0. Then this will be negative 41 over 2, negative 41 over 2. Okay. Now this will be 4, and that will be negative, no, not negative, positive. Yeah, positive 9 over 2. Okay. Positive 9 over 2. Okay, that's fine. That's fine. Now, we have this as an identity now. We have this as an identity now. So automatically, this is our A inverse. Okay, so I can write out my A inverse. So I now say my A inverse is now negative 9. My A inverse is now negative 9, 2, 2, negative 41 over 2, 4, 9 over 2, negative 5, 1, 1. So that is my A inverse. That is my A inverse. Now, using my A inverse, don't forget I have my A inverse. Now I need to now use my A inverse to get my value of x, y, and z. I need to use my A inverse to get the value of my x, y, and z. And how do we do so? We go back. You see, we got A inverse. Now, don't forget we have B there. So this equation, let me write this equation somehow nicely now. So we have this equation, which is A, which is B, and then we have our X. We have our X, which is our X1, X2, and X3. Okay, all right. If you want to rewrite this system of equation, this system is written as AX equals to B. Okay, AX equals to B. That means what I have there is A, which is this one that I have before. That one is A. Yeah, multiplying by our X1, X2, X3 to give us our B, which is 1, 2, negative 1. All right, this is our A, this is our X, this is our B. Now, in order to solve for X, because that is what we are solving for, we make X the subject, then we get X equals to A inverse multiplied by B, because A comes to this side. So now we have X equals to A inverse multiplied by B. Okay, so that means what we need to do is to find the inverse of A, which we have found, and then multiply it by B. Multiply by B, and the value we get will be our X. Okay, so now this is our B, so let's multiply our inverse with B. So we got our inverse. So our X we are looking for will be negative 9, 2, 2, negative 41 over 2, 49 over 2, minus 5, 1, 1, multiplied by our B. What's our B? 1, 2, negative 1. Okay, we're going to multiply them together. Okay, when you are multiplying, you must be sure that they can multiply. This is 3 by 3. This is 3 by 1. So when you multiply together, you're going to be getting the size of X should be 3 by 1. Okay, all right, so let's multiply. So if you multiply this multiplied by this, okay, this multiplied by this is negative 9, this is positive 4, this is negative 2. 2, negative 2. So the answer of that will be negative 7. Okay. This multiplied by this is 41 minus 41 over 2. This is 8. This is 9 over 2. If you do the arithmetic, you are going to be getting minus 17. Okay. This multiplied by this is negative 5. This is 2. This is negative 1. Okay. If you do the arithmetic, you are going to be getting negative 4. Okay. That's what we are going to be getting. Yeah, that's correct. So you see our x equals to this. And what is our x? Our x is x1, x2, x3. That is our x, which is our x, Okay. So automatically, you can see this has the same size. And in equality of matrices, we can now say x1 equals to negative 7, x2 equals to negative 17, x3 equals to negative 4. So we have used the inverse to solve for this system of equations. We have used the method of inverse to solve for this system of equations. So please ensure that you understand what we did.